Alright, in this video or lesson, we're going to start out by continuing our discussion on sequences and series. We're going to look at our standards here. We have MM4A9, which is use and find recursive and explicit formulas for the terms of a sequence. And we're going to recognize and use simple arithmetic geometric sequences. More specifically, in this video, we're going to look at geometric. You can refer to other video on arithmetic. Now, we're going to look at our essential question as being, how do we find the recursive and explicit formulas of arithmetic and geometric sequences? Now, in this case, we're going to look today, in this video, we're going to look at geometric sequences. Now, arithmetic or arithmetic, we know, is we have to add a common difference to get from one term to the next. Well, in geometric sequences, we have what's called a common ratio. The common ratio is you multiply that ratio times the term in front to get the next term. So these are sequences where the ratio of the successive terms of a sequence is always the same number. This is called a common ratio. So again, whereas we had a common difference in arithmetic, we have a common ratio in sequences. Now, let's look at this sequence. Okay, remember, sequence is just a group of numbers that are in some type of order. Now, in this case, we look here, we're going from 1 to 2, 2 to 4, 4 to 8, and 8 to 16. Now, looking at this, it may be obvious that to get from 1 to 2, we're multiplying by 2, and then to get from 2 to 4, we're multiplying by 2 again. Okay, so this is a geometric sequence. Now, to find the common ratio, if we weren't sure of what it was, we can take any two numbers in sequence and divide them. Now, we'll divide, so I'm going to take 2 and 4. So if I divide 4 by 2, I get 2. So that's a common ratio of 2. Now, I can do the same thing with 4 and 8. So take 8 and divide by 4, and we get 2. So our common ratio is 2. And again, we can do the same thing here by taking 16 and 8 and dividing, and we still get 2. The important thing to remember here is that they have to be two terms that are in sequence together. We couldn't take 4 and 16 and come up with a common ratio of 2. But that's how we find the common ratio. So for this one, the common ratio is 2. Now, like the arithmetic, we have what's called a recursive formula and an explicit formula. Now, a recursive formula here is a sub n is equal to r, which again is our common ratio, times a n minus 1. So it's the common ratio times the term in front would give us the next term. So, but to use the recursive formula, you have to list what the first term is. Now, in this case, if we were to write the recursive formula, we would simply substitute in for our common ratio and a sub 1. So our recursive formula here would be a sub n is equal to r, which is 2, times a sub n minus 1, and then we have to list what a sub 1 is 1. So that would be our recursive formula, which we will do some examples in a second, a few more examples. Now, with this, if we want to find the next term after 16, we would simply multiply it by 2, which would give us 32, and so we could plug it into the formula as well, but that would be the next term. Alright, now, we went through all that, and we could come up with this. This is our explicit formula. Now, you'll notice here that we have the power of the n minus 1 to come up with the explicit formula. So this is the general form of the explicit formula. This a sub n is equal to a times r to the n minus 1 power. So if we were finding the explicit formula of this particular sequence, we would simply say a sub n is equal to a, which would be the first term. A sub, well, in this case is 1. So we'd have 1, which really wouldn't be necessary to write, but we'll go ahead and write it for right now, and then we'll look at a sequence that doesn't start at 1 later. Okay, and then r, which we found to be 2 to the n minus 1. So you'll notice there's multiplication here. The 1's really not necessary, so for our explicit formula here, we'll have a sub n is equal to 2 to the n minus 1. Now, if we wanted to find the 5th term or the 6th term or 7th term, we simply plug that number in for n, and it would give us the next term. So let's check our formula based off of what we know. Okay, we know this is the first term, second term, third term, fourth term, fifth term. Well, let's make sure that this matches up. So let's plug in 4. Let's say we wanted to find the 4th term, which we already know from the top. But let's say, make sure our formula works. So we go 4 minus 1. So we get 2 to the 3rd power. We know 2 times 2 is 4, times 2 is 8. So a sub 4 is 8. Okay, so it checks out for our formula. And just to be double check, we could go the 5th term. So we'd substitute in 5 for n. So we get 5 minus 1. So we get 2 to the 4th. Which would be 16, and so our formula is correct. So this would be our explicit formula. Now let's look at some more specific examples, and we'll work through a problem on the next video.